It usually, if it's going to crap out, it craps out after the 22 minutes, but. And then there's a jump in time, and now we're here. Thank you. All right, now, what was all this for? Don't forget, we're still dealing with describing motion. We needed our fourth cake formula. Yes, we do need it. If I take any vector, actually, let's go back to A and B. If my angle here is theta, and I break A up into its components, this component right here will be the hypotenuse, which is A, times the cosine of theta. In other words, A dot B, if I'm dealing in polar form, is just going to be the magnitude of A times the magnitude of B times the cosine of the angle between them when I put them tail to tail. Usually also written as A, B, cosine theta. I have a scalar, my answer is a scalar, the vector parts have all dropped away. Paralleling, or going back to what we talked about before, I hat using that, if I think about that in polar form, the magnitude of the first one times the magnitude of the second one times the cosine of the angle between them, which would be 0 degrees. Cosine of 0 degrees. So we end up with 1. If I did I hat dot j hat, it would be 1 times the cosine of 90 degrees. And the cosine of 90 degrees, 0. So if I do a dot product with itself, if I do A dot A, what does that equal to?
Zero?
Not 0.
Is it A squared?
There we go. It's the magnitude of the first one times the magnitude of the second one times the cosine of the angle between them, and that's 1. So it's just A squared. So any vector which has a dot product with itself is just the magnitude squared. So now we're ready to get the fourth cake formula.
So is that the formula for dot product?
This is a formula for dot product if you're in polar form. If you're in rectangular form, then it would be whatever letters you're using, ax, bx plus ay, by plus az, bz, etc. Depends on how many dimensions you're going in.
Which is different from that, or is it the same?
It's the same. Because what we did over here is, in essence, you're multiplying the I hats together, the j hats, the k hats. All right. So what I'm going to do is I'm going to take two of our formulas over there. I'm going to take the third one we have. So delta x is equal to vi plus vf over 2 times time. And I'm going to take the formula for basically the first one, but solve for acceleration. So I have acceleration is vf minus vi divided by time. And I'm going to do a dot product. Let's put the vector symbols back in where they go. I'm going to do a dot product between the two formulas. So on the left-hand side, I'm going to have acceleration dot delta x. And on the right-hand side, I'm going to have vf minus vi over t dot product with vi plus vf over 2 times t. Now, scalars, I have time here, I have 1 over time there, time is gonna cancel out. I have a 2 here, I'm just gonna multiply both sides by 2, get a 2 over on the left-hand side. So I'm left with 2a dot delta x is equal to VF minus VI, dot product, VI plus VF. I'm now gonna FOIL. Multiply the first ones together. So I have 2a dot delta x, SR, whatever letter you're using, and then I have VF dot VI, outer, plus VF dot VF, inner, minus VI dot VI, and then last, minus VI dot VF. Well, VF dot VF is
Begin squared.
so that's VF squared. VI dot VI.
VI squared.
Now, VF dot VI, they're not necessarily, these are not 0. However, I got that and I have that. Commutative property holds. Does not matter the order in which you do a dot product, unlike cross products. Does not matter the order that you do, so this is going to cancel out because that's positive and that's negative. So what I'm left with is VF squared minus VI squared is equal to 2a dot delta x. Or, more conventional form, VF squared equals VI squared plus 2a dot delta x. So the final speed squared is equal to the initial speed squared plus 2 times the acceleration. Again, we are assuming acceleration is constant. Dot delta x. All right. Let's do an example. And then we'll talk about the lab.
What does 2a times delta x represent again?
It is the dot product between the acceleration and the displacement. Times 2.
I've had it like as a whole represented another thing, but
The difference in the speed squared. Yeah, I mean, there's no single word. A ball is thrown upward initially at 30 meters per second. What is the ball speed when it is 15 meters above the release point? Ball is thrown upward initially at 30 meters per second. What is the ball speed when it is 15 meters above the release point? Whenever solving any of these problems, it's recommended that you, at least until you get much more comfortable with it, to start out with, you got the 5 basic quantities. What do we know?
VI,
Which is?
30 meter per second.
Okay, so at that point, Pratika has now established something that is incredibly crucial for the rest of the problem. What did she establish?
The initial velocity is constant.
None of that.
What was the question?
What did Pratika establish when she told me this initial velocity was 30 meters per second? Because all I told you was the initial speed. But she tells me the initial velocity is also 30 meters per second.
It's going up.
Oh, that's not,
Is it the acceleration?
pardon?
The acceleration?
Nope,
Does that mean that the
So
velocity is constant?
no, velocity is definitely not constant.
Yeah.
Because it's thrown upward.
It is thrown upward. Yes, it is, that's thrown, given in the problem.
Oh.
So the upward is the positive direction?
That's it. That's what she established. Whether up is positive or negative, I don't know. It's whatever you say it's gonna be. Pratika says up is positive. She has now established that. That is set for the rest of the problem, unless you want to work a different problem. But she has now said up is positive. All right, what else do we know?
Displacement is positive 15 meters.
Okay, because it's 15 meters above the release point, so it's on the positive side. So plus 15 meters. We have one other piece of information here that is implied in the problem but not given.
Is it gravity? Being 9.8 or whatever.
Yeah,
Meters per second.
you're on the right track. My hesitation was the wording, but we'll get there. If we're ignoring air resistance, and we are, if we're ignoring air resistance, the acceleration, as long as you're near the surface of a planet, is going to be relatively constant, which is justification for doing the constant acceleration problems, because things that are thrown typically, well, as long as they're going slowly enough, which this is, we're not worrying about air resistance. So my acceleration, first off, is down. Think about the ball thrown in the air problem. We had acceleration was negative the entire time. So it's negative because Pratika said so. And then if we're on Earth, 9.8 meters per second squared. We'll throw it upward, initially 30 meters a second, throw it upward near surface of Earth. If it were Mars, this number would be, I think, negative 2.7. If it were Venus, 7.8. So now, if I know 3 of these things, most likely I know I can find the other 2. The scattershot method is to, given those 3 quantities, plug into all 4 of those equations and see which ones you can solve, or think, what am I trying to find here? I'm trying to find the ball's speed, so I want to find VF. I want to find the magnitude of VF. And I don't know time. So I look at my equations over here and I find the equation that doesn't have time in it. Since I don't know time, I'm not trying to find time. I got that equation right there. So I end up with VF squared is equal to 30 squared plus 2 times negative 9.8 times positive 15. Which is something. Oh, yeah, no, that's right. And the answer is $7 points. What'd you get?
Oh wait, no, I gotta square it in.
Please.
Oh, do you want the decimal number?
Sure.
It's 24.62. Oh. 50.
speed. There we go, meters per second. That is the speed, it is not the velocity. If it is going up, because it's gonna hit 15 meters twice, it's gonna hit it going up and it's gonna hit it coming down. If it hits it going up, then it's positive, the velocity at that point is positive 24.62 meters per second. If it's coming down, it's negative. But this formula is only finding the speed. Questions? Right, now let's shift. That is 4 pages. Take
Four
that,
pages?
4 pages. I'm assuming eventually something will make it switch.